Here we go. Who's my favorite student on quizzes? Oh, it's good old Anne. Anne Serkey. Because she gets everything. Some of you still don't get it. Okay. Solve for the missing variables. Remember, defect 2 marks each. I'm going to give you a half mark for the equation, a half mark for the answer, rewriting the equation, a half mark for the numbers, and a half mark for the answer. In other words, I'm looking for an equation that has a VF, a VI, an A, and a T. I would give you a half mark if you had written this somewhere. Now, if you didn't write that, if you went straight to the rewritten equation, that's fine. You'll get 1 full mark for doing that. But if you blanked, here's what I'm really saying to you. This is probably something you don't ever want to leave a question blank, because I think all of you right now know how to find the equation. That's step 1. How would I get the T by itself? What's going to drop down like a domino? Then, talk to me. Minus VI, then, and that equals T, or I usually put the T equals there. So it's going to be 24.6 minus 3.2 all over 2.5. If this was a physics word problem, it would say something like, a car starts out at 3.2 meters per second and accelerates at 2.5 meters per second squared. How long will it take to reach a final speed of 24.6 meters per second? Something like that. Meanwhile, is this a fraction? More than one thing on the top. I got to put the top in brackets on my calculator. Don't need to put the bottom in brackets. Did you all get 8.56? Now, technically, with the 2.5 and the 3.2, how many sig figs should I technically go to? 2. Who cares about sig figs for the rest of the course? We did our test on sig figs, yes? Okay, we could if we needed to, I'm going to say. So 8.56 units, seconds. So I would give you 2 marks if you got that, 2 out of 2. Otherwise, a half mark if I saw that, a half mark if I saw that, and a half mark if I saw that, a half mark for the answer. I would take a half mark off for no units. That's how I'll mark the rest of these. So if you get it right, 2 out of 2, half mark off if you forgot the units or put the wrong units. And then if you got it wrong, that's where I would give you all your part marks. So I generally take shortcuts in my homework, but I generally show all my work on quizzes and tests because in case I make a dumb mistake or a calculator typo, I want all the part marks that I can get. Make sense, Mason? Good. Number 2. I think the equation is going to be D equals VIT plus a half AT squared. Yes? I got to get the D by its... Oh, it already is. So here, I would give you a half mark for writing down the original equation, and you'd get a free half mark because the D is already by itself. Yay. Plug and chug. It's going to be... I guess we started out going backwards. Negative. We traveled for 19 seconds. We're accelerating forwards, which I guess means initially as we were going backwards, we started to slow down, slow down, slow down, slow down. There's a brief moment somewhere in here where we came to a stop, turned around, and started ending up going forwards, I think, because I think we're going to get a positive answer here. Negative 8.5 times 19 plus 0.5 times 2.5 times 19. Don't forget the squared. Do you get positive 374.75? No, I think I made a typo. I missed a 1 there. I just saw it. And this is why I like a calculator with a long display. It lets me check for typos. Some of you notice you have to backspace and add it. It's a bit of a pain. It's one of the nice things about having like a dual screen or something like that. Let me double check now. That looks better. 290. If you said 289.75, I'll give you full marks, but I have a habit of just rounding to 3 sig figs, so 290. Units, it's a distance, meters. 2 out of 2 if you had that. Otherwise, 1 mark, half mark, half mark. What if I've got a negative answer? I should be fussy. It's not a distance. It's a displacement. The negative would tell me, hey, you started out going backwards, and even though you're slowing down, you're still behind from where you started from. right? This, by the way, if we drew a picture of number 2, it must look like this, going backwards, going back. Somewhere we're slowing down, turn around, going forwards, speeding up, speeding up, speeding up, speeding up, speeding up. And that's where we ended up at the 290 meters in front of where we started from. It would look something like that. A lot of information packed into here. Number 3, same equation. D equals VIT plus a half AT squared. But now I'm going to get the VI by itself. This equation here and the one with the brackets in it are the 2 most difficult equations to work with. VI plus VF equals VI plus AT, kids can almost always do in their head. And you'll get good at the VF squared equals VI squared plus 2AD because it's also mostly adding and subtracting, a little bit of multiplying. These 2 are trickier. Well, drops down like a domino. Do my adding and subtracting next. I think I would subtract 0.5 AT squared. Then what? Then what? Divide the whole thing by t. That is yet another equation for initial velocity. I'm not going to memorize it. I'll practice so I can derive it when I need it. So it's going to be negative 70 minus 0.5 times negative 4.8. What's the negative acceleration telling me? We're slowing down if we assume forwards is speeding up. 24 squared, all divided by 24. I have no idea if I'm going to get a positive answer or a negative answer here. Negative 70. What's the negative 70 mean, by the way? We started 70 meters behind the start line. So from where we're standing with the stopwatch, the car was 70 meters back there. Negative 70. Minus 0.5 times negative 4.8 times 24, don't forget the squared, divided by 24. Is this a fraction? Brackets around the top. I did that. Do y'all get 54.6, 54.7? That's a lot of typing. Units, it's a velocity, so meters per second. If they asked for a direction, I got a positive answer, I'd say forward. Number 4. Squared. VF squared equals VI squared plus 2AD. I would give you a half mark for that. How to get, it wants me to get the VF by itself. The VF is not yet by itself. It almost is. VF squared is by itself. How to get rid of a squared? So I'm going to, because I'm lazy, cross out that and put this whole mess inside a square root. By the way, one thing I learned from a math teacher, if it's a yucky long square root, I always put that little downward hash mark to remind myself that's where I ended the square root. Otherwise, in a big question, it's tough to see, is that inside the square root or beside the square root? So I always put a little down hash, you're going to notice. I'm lazy but organized. Square root of 28 squared plus 2 times 9.8 times 152. I'll put my little down hash there. How am I going to type that? On my calculator, because when I hit square root, it doesn't do a little small mini window. On the newer calculators that have the fancy schmancy fraction button, you can probably do this in one step. I tend to do what's inside the square root first. 28 squared plus 2 times 9.8 times 152. And then square root of that. 61.3. Okay. Now, if this was a word problem, I would have to finish by asking myself, am I going up or going down? Or am I going forward or going backwards? Because it's possible I might want the negative answer of this. But here, 61.3 is just fine. Meters per second. How many of you so far? 8 out of 8. Well done. Okay, remember how weird this was on Monday? Look at it. How are you rewriting all this stuff? We're getting this. Told you. Turn the page. Ooh, same equation. VF squared equals VI squared plus 2AD. Now I'm going to get the A by itself. Okay. VF squared drops down like a domino. Now what? Minus VI squared. And then all divided by 2D. That equals acceleration. Is this a fraction? Yeah, more than one thing on the top. Brackets around the top and brackets around the bottom. Ooh, I also noticed that V final is smaller than V initial. I'm slowing down. I'm going to get a negative acceleration, and that won't make me nervous. That'll make me relax. 22 squared minus 40 squared all over 2 times 96. Negative 5.81. Units, acceleration, meters per second squared. How big is that? A little more than half a G. So now I can start to put that in context after yesterday's lesson. What was 1 G? Who remembers? 9.8, close to 10. So human beings up to 10 Gs, okay. Sustained 8 or 9 Gs, most of you would black out. The astronauts and fighter pilots have to train very vigorously so they can resist that. But generally, up to 10 Gs we can handle. After 25, between 10 and 25, owie, owie, maybe breaking bones, usually above 25. But later on in today's lesson, we'll look at the world record, as far as we know, surviving the highest amount of Gs. Number 6. I would start out like this, VIT plus a half AT squared. And then I would say, wait a minute, they want me to get the T by itself. I can't. Why can't I get the T by itself in this equation? Yeah. Okay. Those of you that did pre-calc 11 or FOM 11 or 12 already, what kind of an equation is this? It's a quadratic. How do I know? It's got a squared in it. How would you solve that? Make it equal to 0, quadratic formula. But we don't know that yet. So if you run into this situation, I guarantee this, I almost guarantee this year that one of your values will be a 0. Or I will show you a clever workaround for a word problem in today's lesson later on. But for now, Caden, are any of these values 0? Say yes. VI is 0, is it not? Good to see you're following along. So really, I have a special subcase of D equals VIT plus a half AT squared. It would look like this. AT squared. And you can either write it like this, Shay, 1/2. Does that 1 make a difference at all, timesing by 1? So I tend to write it like that. Or some people like to write it as D equals 0.5 AT squared, because for them, fractions are the math F word, not the F word you're thinking of. I don't care, really. You can use either or. If I was going to get the T by itself in this equation, I think what I would end up doing is timesing the 2 over and dividing the A over. That would give me a 2 times the D, which would drop down like a domino, divide by A T squared. How to get rid of a squared. This one we're going to use, by the way, fairly often. This concept of VI is 0 and we want to find T. This is how we're going to figure out how long it takes for an object to hit the ground if it jumps out of an airplane or falls off of a cliff or something. That's part of today's lesson. Or, Mason, if you did this version, you would drop the D down like a domino. You would divide the 0.5A and you would have a T squared. How to get rid of a squared? Square root. Those are identical equations. I just like this one better because to me it looks prettier because there isn't a decimal inside of a fraction, but whatever. It's going to be 2 times 240 divided by 10. 6.9? Works out to 48. Square root of 49 is 7, so it's going to be a little less than 7. 6.93. I should have just made up that last number and fluked. Maybe I might have fluked into a 3 sig fig guess. 6.93. Mr. Dewick, let's move this over a little bit so I got some room. And that is seconds. Seven and 8 were the toughest. Okay? And I deliberately, during the lesson, tried not to do ones like this because I really do believe if I teach you how to do formula manipulation, you can figure stuff out on the fly, Alicia, if you need to. And if you get this wrong, that's okay. Do your corrections and you get the full marks. But I wanted to give you a chance to have a quiz-like pressure situation where you were, I haven't seen this before. Don't panic. What equation? Well, D equals VI plus VF times T over 2. Yes? What am I trying to get by itself? Okay. What's the 2 doing to the T? What's the bracket doing to the T? So how will I move the bracket over? Divide. Oh. So, Mr. Dewick, you're telling me that equals T? Yep. And I'll pause now and say, did I actually do anything new there? I hope not. I just didn't panic. Said, okay, what's going to drop down like a domino? Get reverse bedmass, so deal with the bracket last, which I did. And what's the bracket doing? Timesing, so divide the bracket. Oh, by the way, there's an implied bracket there because we have to type one into your calculator. So you can put it there if you want to. But when you handwrite it, we understand there is a bracket there. How many of you got that equation? Nice. Good. 2 times 2400 divided by 5.5 plus 20. Brackets around the top. And definitely brackets around the bottom. Did you all get 188? Well done. Units, it's a time, so seconds. Eight. Same equation. Okay. They want me to get the VI by itself. There it is. What is the VI inside of a bracket? Ooh, reverse bedmass. What are we going to deal with last? The bracket. So I'll do my adding and subtracting. Is there any adding and subtracting outside of the bracket? If there was, I would minus or plus them over as I needed. Okay. What's the 2 doing to the bracket? So the D is going to drop down like a domino, and I'll times it by 2. What's the T doing to the bracket? Timesing, so how will I move it over? The opposite of everything Caden is saying. That's probably a good life motto. Anyways. Now, here's what I have left on the right-hand side. In my mind, I imagine that. How would I move the VF over to get the VI by itself? And you'll notice the VF isn't going to be divided by the T. It's going to end up looking like this. Although, do you mind? I'm going to put the VI equals over here. It's going to look like that. That's okay. It's going to be 2 times 120 divided by, I think I can do this in my head. Sure I can. 2 times 12, 20, negative 4? Yeah. Okay, I'll even go to 2 sig figs. Heck, I'll go to 3 sig figs because I can, because I did it in my head to show off. Meters per second. So 2 marks for each of these, making this quiz out of 16. Can you give yourself a lovely score out of 16? If you want to lawyer with me, now is the time. Otherwise, make sure your name is on them. Make sure there's a score. And if you'll be so kind as to pass them inwards, the person in the middle will put them in a nice, neat pile, all facing the same way. Yeah. Can you see 8? Most common mistake with number 8 is kids put the VF on top of the fraction and divide it by t as well. No, not in my reverse bedmass. Nuh-uh. Freefall. Before we start Freefall, I did say to you that we were going to look at the world record for surviving the most G's. Maybe someone has survived more than this, but we didn't capture it on film, so we couldn't analyze it. This is the one that we happen to have captured on film. In 1977 in Northamptonshire, England, David Purley's race car crashed, and his speed dropped from 174 kilometers per hour. Oh, Mr. Dewick. Cross out the 174 kilometers per hour. Nice try. What do I want to convert that to? What do I want to convert it to? Meters per second. How will I do that? It's something. Is it divided by 3.6? So what do you get? 174 divided by 3.6. Oh, I totally did that wrong. I got an answer button on here. 174 divided by 3.6. 48.3. So I'll write 48.3. I'll try and use my answer button if I can on my calculator because it is 48.33333. But I'll just write up here really small 48.3 meters per second. In 0.66 meters, so 174 kilometers to 0 in about this distance. That's about point, because a meter is about like that. So 0.6 of a meter, about like that. That's a pretty rapid stop. He had 29 fractures. He had 3 dislocations. His heart stopped 6 times. He did survive, but he was permanently injured, but he survived. So this is what we have on record. How many G's did he experience? On your test, I will ask you at least once to calculate how many G's. You can't. First, you calculate the acceleration. And then once you have the acceleration, what do we divide that by to figure out how many G's? 9.8. Okay, so I'm not going to remind you of that anymore. I'll just say how many G's, and I'll expect you, Hannah, to clue in. He really wants the acceleration first. So that's why I'm going to write first A equals question mark. What's that 48.3? VF? Oh, is it VF or VI? What's VF? In pretty much any car accident, I'm pretty sure it's 0. Okay? So VF is 0, which means by logic, this must not be VF, it must be VI. What's that 0.66? How do you know it's displacement or distance? Meters. This is why I said it's worth memorizing the units, because I didn't put any descriptive, I didn't say in a distance of 0.66, I just said in 0.66 meters. My units all match. As I was reading, I did the conversion, so we're good. Which equation? Stop. Get the A by itself. It is the VF squared equals VI squared plus 2AD. So now let's see if we can go straight to writing the modified equation as A equals. What's going to drop down like a domino? The VF squared, then what? Minus VI squared, then what? Divide by 2D. Nice. I'm kind of just reading the vibe in the room, but as a group, you are picking this up pretty much as fast as I've ever had a group of kids pick this up. Now, if you're still struggling with this, that doesn't mean, oh, I'm dumb. I don't. No, come in and I can totally get you on this just fine. But I will say, as a group, you're buying into this. It's nice. Sometimes I really have to force kids into this because you're making me do algebra, Mr. Dewick. I want to use my calculator. Yeah. 0 squared minus 48.3 squared. When I said that, Sophia said, what? There's some teachers that would teach this way. They would say, oh, 0 squared equals 48.3 squared minus 2 times 8 times 0.66, and they would do this plugging in numbers right away and do everything by equation solving. I'd rather do my algebra first and plug my numbers in last. All over. Some of you have raced ahead already. Oh, by the way, are you going to get a negative answer or a positive answer? I think he most definitely slowed down. Do you get negative? Oh, do you get negative 1,767? Now that's meters per second squared. How do I convert that to G's? $180 G's. Or having 179 of him dogpile on top of himself. So when I told you, 25 and bigger is fatal, actually we saw some videos of Colonel John Stapp surviving bigger. There are ways to survive larger. There's a lot of variables involved. Much of it is what angle you hit it at. Much of it is, really though, the point is what does damage in an accident is not your speed, it's your acceleration. It's your acceleration, okay? By the way, this is an interesting equation. I just told you what does damage in an accident is the acceleration. How could I make the acceleration smaller? Well, the obvious first one is, Mason, slow down at the beginning. Because if the top number is smaller in a fraction, I'll get a smaller answer. But how else can I make a fraction smaller? Yeah. What? How do I make the distance bigger? That's what crash pads do, or hay bales in motorcycle races. All they're doing is they're lengthening how long the collision lasts for by making your slowing down distance bigger. It makes the acceleration smaller. Ta-da. There, we've just come up with the fundamental concept that we use in crash test dummies and car safety. It's all about making the acceleration smaller. Now let's look at freefall. That was just nerd trivia. When an object is falling through the air, we say it is in freefall. Now, I have to be very careful. By falling through the air, I don't mean moving down. Look up. The tennis ball that I tossed was in freefall on the way up and on the way down. What we really mean by freefall is the only force acting on it is gravity. So on the way up, the only force acting on the ball was gravity. That's why it slowed down. On the way down, the only force acting on the ball was gravity. That's why it sped up. If we ignore air resistance, which we're going to do. So remember the video I showed you last day of the feather and the bowling ball falling at the same rate. Okay? In free fall, acceleration is always negative 9.8 meters per second squared. What's the significance of the negative? We're going to decide to let down be negative and up be. Easy way to have our vectors and our directions without having to write the word up or down all the time. Of course, that negative 9.8 changes in other places. On the moon, for example, it's about negative 1.6. On Jupiter, Jupiter doesn't have a surface, it's a gas giant, but if Jupiter did have a surface and you stood on it, it's about 26 meters per second squared. You'd feel much heavier. In outer space, away from any planets, 0. We'll talk about gravity more next year. I'll show you how you calculate some of these values, but that's a Physics 12 topic. That's Isaac Newton's law of gravity, if you've heard that term before. Free fall is cool. Put your pencils down, look up. I like example 2, I like example 2, I like example 2. Example 2 is a nice question. How many of you have ever stood on a cliff and dropped rocks down safely when no one was down below somewhere, out in the wilderness somewhere? How many of you have ever chucked rocks over a cliff? Okay, kind of a fun thing to do. If you're ever in such a situation, it's pretty easy to figure out how high the cliff is by timing how long it takes the rock to hit the ground. like this. So a cannonball is dropped from a cliff, hits the ground 10.6 seconds later. How high is the cliff? What's this question asked me to find? Well, it says how high. Of our 5 physics things that we've been looking at, which one of those do you think would be a height? We're going to get a displacement. We're going to call it height in English, but we're solving for D. Okay. Who remembers from yesterday, if we drop something, what's VI? I'm not going to tell you that anymore. If the question says dropped or implies that we've dropped it, we can assume VI is 0, so I'll write that here. And as soon as you drop an object, I know what its acceleration is. What's it accelerating at? I'm not going to tell you that in the question. I'm going to expect you to clue in. It's in free fall, negative 9.8. Oh, what's that 10.6? What's that 10.6? How do I know it's time? Seconds. Looking for an equation that has a D, a VI, an A, and a T in it. Jordan, which equation? Jordan, you made my little math nerd heart sing. Because here's what I was prepared to do. Usually kids say D equals VIT, and I cut them off and I say, don't waste my time. Because VI is what? So I love the fact that you anticipated and gave me the shorter version already. You said, Duick, actually, I can just write D equals a half AT squared, which Shay, I usually write as AT squared over 2 because I'm too lazy to write the 1 if I don't need to. Okay. No, need to get the D by itself. Ha! Ready is. Okay. What's A, Jordan? T. 10.6 squared. If you're out in the wilderness and you don't have a calculator handy, basically time it on your smartphone, square the time times 10 divided by 2. So really, what is 10 divided by 2? If you square the time and times by 5, that's roughly the height of the cliff. You can survive just fine without that, but I live in the hope that somewhere, someday, you'll be hiking somewhere and you'll come to a deserted canyon somewhere and you'll get a chance to throw some rocks and, oh, I know how high this is. What do you get? You get a negative answer. Yes? Negative what? I heard 500 and something. 550? So negative 550 or negative 551? If we round off to 3 sig figs properly. Why negative? Because we found a displacement, not a distance. Did the rock end up below or above from where we started? Should be negative. Okay, is that all right, Hannah? That's a pretty high cliff. I wanted to make up a pretty dramatic example. What else would I like to know? I'd kind of like to know the impact velocity. Which velocity is that asking me to find? V final. Now, common mistake. Kids say, Mr. Duick, isn't V final 0? V final is 0 after you hit the ground, but not when you hit the ground. If you don't believe me, do a belly flop onto the cement. It will hurt. And the reason it will hurt is because when you hit the ground, V final is not 0. If V final when you hit the ground was 0, it wouldn't hurt. So this is asking me to find, I totally agree with you, Sarah, V final. Sarah, I think I still have everything listed right here, so I'm not going to rewrite it here. Although I know D, I'm going to try and avoid using D just in case it's wrong. So can you find me an equation that has a V initial, an A, a T, and a V final in it? Alicia, which one, kiddo? Because you have your green sheet out in front of you like I suggested, right? Yes, I totally called you on that. Sorry, that was mean of me. Yeah. I need to get the VF by its... Oh, ha! Already is. Oh, you wasted my time, Alicia. What's VI, people? So, Alicia, you could have just said VF in this specific case equals AT. Which, by the way, if you're standing on a cliff in the wilderness somewhere, Donald, and you want to know how fast the rock hits the ground, approximately, time it and multiply by 10, you're pretty close to figuring out how fast it hit the ground at. Negative 9.8 times 10.6. What's the significance of the negative? Which way is the rock traveling when it hits the ground? Down. So this is giving me a velocity, not a speed. It's giving me a vector answer. Direction is taken care of. Going to be what? Really close to 100? Negative 104, if I round off properly. Meters per second. Now, I got to be honest. A cliff this high, air resistance probably would play a big role. This rock might even hit terminal velocity. Okay, but you know, a cliff 30 or 40 meters high, no. Or, I didn't grow up in Pitt Meadows. I grew up out in Abbotsford. Is there a lake somewhere that has good cliff jumping in the Pitt Meadows area that you all know about and go to? Because if you have a waterproof watch or a waterproof phone, you could jump up, time yourself while you're in free fall, and you can figure out how high the cliff is. Or you can have a friend watch and video you, or a friend watch and time you, and you can figure out how high you're jumping from. Which I think adds to it. You've probably wondered some of these questions if you've ever cliff jumped somewhere. No, none of you have cliff jumped. Okay, fine. Jeez. C. C. Braden, what's C asking me to find? Which one? VF or VI, do you think here? You're right. How did you figure that out? One hint is after. See the word after? So, okay. VF equals question mark. What's that 3.6? So things have changed. I'm going to rewrite what I know I can still use. Can I still say that VI was 0? Okay, so I can drop that down. Can I still say that A is negative 9.8? Yep, I can drop that down. Could I use the distance value or the V final? No, because those were for a different time value. Looking for an equation, Braden, that's got a VF, a T, a VI, and an A in it. Which one? He's getting his green sheet out. By the way, if you don't have your green sheet out, I'm probably going to call on you. Oh, don't waste my time. So it's going to be negative 9.8 times 3.6, still negative. By the way, what if I get a positive answer? That tells me it's on the way up. That probably means I threw it up in the air before it came back down. We'll look at one like that as well, Adam. You get negative 35.3? Going once, going twice. Negative 35.3, yeah. Units, meters per second. Cool. Cool. Xavier, what's D asking me to find? And I'm going to be fussy. Probably a displacement. I'll bet you I'll get a negative answer because I think I'm below from where I started. Now, we're going to start out, by the way, just dropping an object off of a cliff. And then a couple of questions from now, we're going to throw an object up from the ground. And then a couple of questions from now, we're going to throw an object up from a cliff. So if we're throwing it up, it is possible to get positive answers for those ones somewhere along the way for some of this stuff. The toughest question, which is physics 12, is when we're going to ask, what if you throw it off of the cliff but at an angle in an arc? And that's when you really need the quadratic formula, but that's physics 12. So you said D? I agree. What's that 3.6, Xavier? Is that the same time as in part C? Did I list everything in part C? I'm going to be lazy since it's sitting on your page. I'm looking for an equation that has a D, a T, a VI, and an A in it. Xavier, which one? Yep. Again, I'm pretty sure this is going to give me a vector displacement answer. So it's going to be negative 9.8 times 3.6 squared all over 2. You get negative 63.5. Okay. And that's going to be what? Displacement meters. All right, instead of just dropping something, let's throw something. A ball is thrown straight up with a velocity of 29 meters per second. By the way, what if I stood on a cliff and threw it straight down? How would I show that I'd thrown it down? Not 29, but negative 29. And then the physics will take care of itself. These equations will work in any direction. But anyways, blah, 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 blah. What's A want me to find? Donald, my friend. What's A asking me to find? How long is vague? I need to figure out, is this distance, displacement, or time? What? I agree. Okay. Donald, what's that 29? Yep. Oh, we're in free fall even though we're on the way up, so I still know what's A, Donald. Because the only force acting on it is gravity. Problem. How many things have I written down? 2. How many do I need? So I guess I can't solve this. Or can I? Caden, what are you going to suggest? At the top, for a split second, right when it's changing direction, how fast is it traveling exactly? VF is 0. I'm not going to tell you that. I'm going to expect you. I'm making the assumption that you've thrown things in the air as a child or played catch or watched it and have noticed, oh yeah, it does come to a stop for a split second. Donald, looking for an equation that has a T, a VI, an A, and a VF in it. There is one. Get the T by itself, please. I'll give you a hint. T equals. So I'm going to go like this. What's going to drop down like a domino? I know VF is 0, but because it's the only thing all by itself on the equals that side, I'm not going to cross it out because then I end up with nothing and it's hard to keep track. So VF drops down like a domino. Then what? Then what? Yeah. So the only time I don't cross out a 0 is if that would leave an entire side of the equation blank. It just gets creepy then. So 0 minus 29. Oh no, I'm going to get a negative answer. Time has to be positive. Oh, I'm dividing by a negative. I have a negative divided by a negative. I'm positive, which good. Time is the answer. Will always be positive. If you get a negative time, you've messed up. I saw a movie once where they went backwards in time. No, time is positive. Okay? Donald, did you get negative 2.96? Yeah. Did I say negative? That was terrible of me after that rant. 2.96. Look, this is harder than it looks, okay? Turn the page? Sure. Oh, by the way, I should have said to you, I like example 3, I like example 3, I like example 3. Example 3 is a nice question. These are questions that I can ask you about free fall. These are kind of interesting questions. Hey, what's the maximum height reached by the ball? Kai, what's this asking me to find? I'm going to get a displacement, and am I going to end up above or below from where I started? I better get a positive answer here. If I get a negative answer, I'll get nervous. Let's make our list. VI was, what did I launch it at, Mr. Dewick? 29. A is negative 9.8. VF is 0. Which equation, Kai, my friend?
F squared equals
Get the D by itself, please.
F squared minus X squared divided by 0.
So I'm going to get D equals 0 squared minus 29 squared all over 2 times negative 9.8. Is this a fraction? More than one thing on the top? I'll have to put brackets around the top. I have to put brackets around the bottom. Show me your calculator. No, show me your calculator. I think, do you have the fancy? No, you don't have the fraction button either, so we got to do it the old-fashioned way, you and I. Do y'all get 42.9? Units, Kai? Okay. Put your pencils down, look up. Let's suppose this was a test question. Hint, hint, hint. Let's suppose this was a test question, and I finished the test early. I could also use this and use my time answer from part A. So I might really quickly, either on a scrap piece of paper or in the margin, just get up my calculator and go 29 times. What was T? What did we get for part A? 2.96 plus 0.5 times negative 9.8 times 2.96 squared. And if I also, did I type this totally wrong or what? Sorry? I forgot the 6? 2.9. That's not going to make that big a difference. Oh, I put 29. No, 29 times 2 VIT plus a half A 2.9. I did plus 5 times, not 0.5. Thank you. I knew I made a typo somewhere. So sorry for stealing my punchline, but I get the 42.9. Does that mean I must have got A right as well? I have to have gotten A right as well. How could I have fluked into that otherwise? So there's ways to check your answers by now, you often have more than one way to find something, okay? Tricks of the trade. C. What's the impact velocity of the ball just before it hits the ground? That's a good question. Logan, what's the answer? Too slow. Caden, what's the answer? Too slow. Garrett, what's the answer? Too slow. Okay? And I'm not trying to make fun of you. I am saying, look, are we starting on the ground? Yeah. Are we ending on the ground? Yeah. What did we leave the ground at? What was our initial velocity? You know what our final velocity that we hit the ground at is going to be? There's a saying that says, what goes up must come. Mr. Dewick, airplanes don't come down. Yeah, I'm using this as a dumb way to remember. For what it's worth, if you start and end up in the same place and we ignore air resistance, you're going to come back down at exactly the same velocity that you left. Because whatever you lost going up, you're going to gain right back coming back down. Okay? That's handy. Now, what if you couldn't remember that? You can calculate it, I guess, but I'd rather just have that in my back pocket, that if I'm starting on the ground and ending on the ground, my initial and final velocities will be the same magnitude, but Sarah, just opposite signs. Okay? If I had given this to you on a test, I might have hinted by making B 2 marks, but C 1 mark. Usually if I make something 1 mark, that's my way of saying, you probably know this already if you're clever. Okay. D. For how long is the ball in the air? Didn't we find that in A? Or did we? What did we find in A? Sorry? I don't think we found maximum. Do we find maximum height in A? No, I think we found time. Isn't that how long it was in the air for? How can I figure out how long it was in the air for? I think you're right, but I can't hear you. Can you say it louder, Sophia? Sophia, can you read this to me, please? What goes? What? Times what by 2? Let's use nouns and not pronouns, please. Times what by 2? Okay. If I know how long it took to get to the top, it's going to take the same amount of time to come back down. As long as, Hannah, we're starting and ending at the same place. This does not work for a cliff because you're not ending up where you started from. Okay? Can't use that shortcut there. So I can take, here's what I'd like you to do, by the way. Can you draw a line in the middle of your page only about 1/3 over, leave about 2/3 of the space? One way to do this is to go like this. Take your answer from A times 2. Okay? And because I had done A already, that's what I would do. So I'm going to scroll back, and I'm going to be really, really nitpicky. I'm going to go 0 minus 29, close bracket, divided by negative 9.8. Instead of using the 2.96, I'm actually going to use my answer button times 2. And if I do that, I get 5.918. I'm going to write 5.92, but can you remember that number? Okay. Just show you something kind of nice. So was it 5.92? I'll call that, how about T total? 5.92, just so I don't get it mixed up with the T from part A. What if I hadn't done part A already? You could totally do part A on your own, Jordan, and double it, but I'm lazy. I'd rather get there in one step. If I hadn't done part A already, I would say to myself, self, you want me to find that? T total. What was VI? 29? No, yes? Yeah. What was A? Negative 9.8. Ooh, what was V final when I hit the ground that we just wrote in part C? Negative 29? Looking for an equation that has a T, a VI, an A, and a VF in it. There is one. Turns out it's the same equation as we used right here. Just different values. T equals VF minus VI over A, negative 29 minus 29, all over negative 9.8. And if I do that, bracket, negative 29 minus 29, all divided by negative 9.8. I don't know if you can see in the back, but those of you in the front, you can see bang on the same answer on my calculator to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sig figs, but really to an infinite number of sig figs. I don't care which method you like. I flip-flop. If I already know time to top, it's lazier to double it. Done. If I don't know time to top, it's lazier just to solve it in one step rather than find time to top and double it. And I'm lazy, but organized. E. What's the displacement of the ball once it hits the ground? Donald. Yes! No, not I mean. Absolutely, it would be 0. How high were we when we started? 0. How high were we when we finished? 0. What's our change in position? What's our displacement? 0. No ifs, ands, or buts. Yeah. Pardon me? Well, okay, that's a good point. We're launching it, let's say, from a cannon that's built into the ground. Donald said, you can't throw something in the air from 0 meters. You're right. Or we're imagining that we're laying on our belly and somehow throwing it. Yeah, we're in our magic physics world to keep the math nice. I used to have a question in here where I measured the height from a person's hand to the ground, and we just added that 1.3 meters to everything. I nuked it this year because I felt I was being too pedantic. That's a fancy word for too nitpicky. Clearly, I wasn't being too nitpicky. I should have kept it in for you. My bad. It's a great point. I like example 4, I like example 4, I like example 4. Example 4 is the next question. By the way, have I taught you anything new so far? I kind of hope not. I hope I've confirmed a few educated guesses, Alicia. Oh yeah, it is 0 at the top for a split second. But I'm hoping I really haven't, like, wow, I never saw that before. So I'm hoping I planted the seeds already. So let's keep going a little bit here. How much more am I doing, Mr. Duick? A few more. Okay. Let's do this. I'm going to pause for a second.